Traditionally, embedded optics have been proprietary-based solutions, and we knew that as we progress the technology through the industry, as we move from 10 gig to 40 gig to 100 gig to 400, and whatever speed comes next, the ability to continue to use faceplate optics were kind of presenting greater complexities. One, the thermal environment was getting a little harder to deal with. Signal integrity was becoming more difficult to deal with. The fact that you had people plugging these modules in, which were very sensitive to ESD and sensitive to noise and the damage that you would have from them. And we decided that we needed to start the progression of moving the optics away from the faceplate and closer to the ASIC, if not onto the same footprint of the ASIC eventually. We knew that at 400 gig that it was possible to do faceplate pluggable. We knew in time people would figure out how to do optics embedded with ASICs. But what was going to be the thing that would allow us that transition in between? What would allow us to have the learnings and the understanding to understand how that would change our business models? And that's why we came up with Kobo. This is a little Kobo module. It's by 16 wide, which means it's a 16-lane interface on this side. And this one was designed for output of 4 100 gig PSM4 signals. This is the medium size version of the module. It comes in a by 8 and a by 16 version, so if you take half of this, you get a by 8 version. It comes in 3 lengths, slightly shorter than this length, and slightly longer. That allows us to be able to use this module literally from multimode fiber all the way up to long-haul coherent transmission. The module in its widest form factor is capable of accepting up to 40 watts of power to drive whatever componentry we need in it. It's capable of having a full 1 RU of heatsink or greater. If we want, you can even do liquid cooling on this if you want. There's the capability of latching either on the high-speed pins or the low-speed pin connector on the bottom. We separated the low-speed power and ground and control away from the high speed to improve the signal integrity. The nice thing is these pins on the bottom are 0.8 mil pitch, which means that we get lots of good contact and power. And these ones are 0.6 mil pitch, which we've done investigation on, which means that they should be able to handle up to 100 gigabits per second PAM4 electrical signaling, which means that this module in its future instantiations will be capable of 1.6 terabits worth of bandwidth.